Good day everyone, I'm Injun Kadachariana and my topic is all about feedwater system. So what is feedwater system? Feedwater system is a crucial component of steam boilers, responsible for the storing and pumping water directly into the boiler. There are two types of feedwater system. First is the open feed systems and the closed feed systems. An open feed system is used by ships on their auxiliary boilers. In this system, feed water is pumped to the boiler where it is superheated and then fed to the various consumers on ships. For instance, tank heating, oil purifiers, fuel conditioning system, and etc. The steam once used will be drawn to the condenser. Closed feed system are used for very high pressure application. For example, a big turbine needs a big amount of steam to be moved. The steam utilized by the turbine will go to the condenser. A condenser at a high vacuum will allow heat exchange to take place with a conservative drop in temperature. Condensate will be drawn by extraction pumps and circulated on air ejector where the air is removed. The components of a feed water system may vary depending on the specific type and design of the system, but some common components include: first is feed water pumps. These pumps are responsible for delivering water from the feed water source to the boiler. They can be either centrifugal or positive displacement pumps, depending on the system requirements. Next is derailleur. A derailleur is a device that removes dissolved gases such as oxygen and carbon dioxide from the feed water. This helps prevent corrosion and pitting in the boiler and other system components. Next is feed water storage tank. This tank stores a reserve of feed water to ensure a constant supply is available for the boiler. The tank may be pressurized or atmospheric, depending on the system design. Lastly, feed water control system. The feed water control system regulates the flow of feed water into the boiler to maintain the desired water level and pressure. It typically consists of various sensors, transmitters, and other controllers to monitor and adjust the feed water flow.
So, the second is the steam service system. A steam service system is composed of several components that work together to generate and distribute steam. The major components of the steam system are boiler. So, in the boiler, heat is added to liquid water to generate steam at a certain pressure. Boiler pressure is used to control the thermal capacity of the steam and to motivate the steam through the system. And the second is the steam header. Steam header is a large pipe that distributes steam from the boiler to the rest of the system. It is typically located at the top of the boiler and, and is used to balance the flow of the steam to different parts of the system. And then the steam manifold. So it is a smaller diameter piping connects the steam header to a certain manifold. So the manifold serves as the branch point of supply the individual heating circuit. Steam manifold commonly have 4 to 16 branches, and each branch contains an isolation valve. A steam trap is located at the bottom of the manifold for removing any condensate from the manifold. And the heating circuit. Heating circuits are the pipes that carry steam to equipment that needs to be heated. They are typically made of steel and isolated to prevent heat loss. Each heating circuit has control valve that regulates the flow of a steam to the equipment.
Condensate manifold. Condensate manifold is similar to the steam manifold, but it carries condensate water that has condensed from the steam back to the boiler. Each branch of the condensate manifold contains a steam trap to remove any remaining steam from the condensate. Steam trap. A steam trap is a device used to remove non-condensable gases from the steam system. It is typically located to the lowest point in the system and works by opening and closing in response to changes in pressure. Control valve. Control valve regulates the flow of the steam to equipment being heated. It is typically located near the equipment and can be manually or automatically operated. Insulation. Insulation is used to prevent heat loss from the steam system. It is typically made of fiberglass or mineral wool and is applied to the pipes and equipment. Expansion joint. An expansion joint is used to absorb the construction of the pipes due to changes of temperature. It is typically located near the pipes to move without causing damage. Pressure relief valve. A pressure relief valve is used to prevent the steam system from becoming overpressured. It is typically located near the boiler and opens automatically when the pressure exceeds a certain level.
Boiler fuel oil system. The boiler fuel oil system is a component of a boiler that supplies fuel oil to the burner for combustion. So here are the main components of a boiler fuel oil system. First is the settling tank. So settling tank is where any water in the fuel may settle out and be drained away. The oil from the settling tank is filtered and pumped to a heater and then through a fine filter. Next is the burner. Burner is one of the most important parts of a boiler. It mixes the air with the fuel source, resulting in combustion, which provides the necessary heat to heat up the fluid. The burner provides heat input by combustion of a heat source. So in other words, it initiates the combustion reaction within the boiler.
This is the component of the boiler where the fuel is burned to heat the water. The chamber contains the burner and designed to provide a very safe area for high temperature. Usually made of steel or cast iron or another heavy-duty metal that can cope with a temperature reaching several hundred degrees. System control. This allows the user to set water temperature, air, and fuel supply mixture to internal pressure and ignition. The control regulates how often the burner fires, the quality of the mixture of fuel and oxygen, the rate at which the fuel is used, and how to the water gets. The controls are also an important part of the safety. In summary, the boiler fuel oil system has four main components: the settling tank, burner, combustion chamber, and system controls.